Hi. I thought I would slowly go through an R Markdown script that covered the analysis that we did in Lab 7 last week. And it has some commands that we've mentioned before, and you've seen them in some tutorials. And I thought you might enjoy seeing them, how to make a really good report. So we'll talk in this video about the code in the R Markdown, and then in the next video, we'll talk about the analysis, about what to write about this code and this analysis. So I'll let me just annotate here with the pen. We start off as usual with a YAML with a YAML. In this, we have the title. We have a title that really indicates what this is about. We have the date. We have the name or names of the person. So always important, remember to put that at the top. Our first code chunk is here. Remember, a code chunk starts with 3 backticks. So they're there. Then we have the brace. Then we have the letter R to tell R Markdown that the code is in R. Then each code chunk can have a name. The only rule is you can't have the same name. So each code chunk can have a name. We're going to call this one setup. We're going to include the most general include equals false option here so that nothing from this code appears in our report. This code chunk will load the library commands. This code chunk will read the CSV file that's given by this website address, and it will read it and call it NLSY. So the object that we'll see here is NLSY. I'm going to clear out, I can't do that now since I'm just highlighting things. So we have NLSY is going to be the object. We're assigning, this is the assignment operator, we're assigning the CSV file that we've read to this object NLSY. Our next command is going to drop 2 variables. We're going to use the select command to drop row names and ID. We have the negative sign in front, the dash, telling R to not select those 2 variables. We use our pipe syntax where we start with the data frame, NLSY, we pipe it into the select command, and then we assign what's resulting, which is dropping those 2 variables, back to NLSY. We're going to use the same syntax, so this is a very common syntax in R. We're going to modify the NLSY dataset with the mutate command by creating a new variable. This new variable is going to be called ethnic group, and it's going to be equal to a conditional statement. If black is equal to 1, then ethnic group is going to be equal to black with a capital B. Otherwise, if Hispanic is equal to 1, we're going to call ethnic group Hispanic, and anybody else we're going to call other. So we're only going to have 3 groups here. Other would presumably be whites, Asian, other categories are all being lumped together. Notice how we have 3 closed parentheses here. This one closes this. This one closes this, and this last one closes our first one there. So we always have to have our parentheses balanced. Then we can go on here. Let's see, I need to switch. Let's go down here. We're going to create a new variable here that is the anti-log of the log wage. Our data set had the log of wages, LNY, so we're going to raise E to LNY, and that will give us the wage. So remember, the exponential function is the inverse of the log function. So by raising the exponential function, E, the 2.718 ... by raising that to this value, which is the log of wages, that gives us the underlying wage. So we generate that, and then we also generate a version of the highest grade completed that is a factor variable version to tell R we want these to be in categories. We'll see that's useful for the box plot down below. So that's our first code chunk. Then we're going to go, I'm going to skip the analysis here and go down to the second code chunk. Our second code chunk is going to contain the data summary command. We're going to look at the mean, standard deviation, and median, and number of observations of these variables. So all of these variables in this data set, NLSY, we're going to give it a formatting for the output that'll be a little nicer than the one that you've had so far, just make it a little bit better here. And then we have a nice title that explains clearly what we're doing. Now we're assigning this to the object XX, and then what we're going to do here is pipe XX into a format called Cable Classic. And we'll see, you can see over here, this is what the format looks like. It's a little nicer with a bold underline. The default format and data summary is not quite so nice. So this is all this is doing is changing the format of the table. If you follow this syntax exactly, you could produce a table that looks just like these tables look. So it shouldn't be any difficulty for you to copy and paste this and adapt it to whatever setting you're considering. So that's our table of descriptive statistics. Now we're going down to our next code chunk. Notice how I've called this F1. And now I have a bunch of code chunk options: echo equals false, comment equals NA, message equals false, warning equals false. There's no excuse for you not to know these. You just copy and paste these from now on so that your report will be nice and clean. So I'm going to take NLSY dataset. I'm going to pipe it into this filter command, and I'm going to drop all the people who have really high wages. There's not that many out of the 6,400. There's 50, less than 50 that have these really high wages. That makes all the plots look better, and I'll always have a note, like I do here, that I've dropped those people with high wages. So this is going to be our standard geom point, a scatter plot, with the unemployment rate on the x-axis and the wage on the y-axis. It's many of you in your reports put the log of wages on the y-axis, but the log of wages is really hard to understand what it is. Most of us don't have any intuition about the log of a number, the log of the wage. What does that even mean? So that's why it's good to make the graphs with the untransformed value of the variable, so the wage rather than the log of the wages. That's our scatter plot, and you'll be able to copy and paste that and adapt that as you like. And then we have a box plot here. So I'm going to do a box plot where we're going to have the highest grade completed, the factor variable version of it. So the x-axis is going to have each level of grade completed, 7, 8, 9, 10, 11, 12. The y variable is going to have the wage. The box plot gives us the distribution of wages for each one of these categories. So it gives us the 25th percentile, the 50th percentile, the 75th percentile, the distribution and outliers of wages for each one of those categories of highest grade completed. And we've got some extra stuff here. We're going to add the mean. So in addition to the 25th percentile, the median, the 75th percentile, we'll also have the mean as a little dot, kind of asterisk, the shape 8, make it a little asterisk that we'll color blue. So we'll see the mean value too. The mean and the median are always interesting. Notice that I always use theme BW. I think that graphs figures look better. Notice that each component of the command has a plus sign after the end of each set of options. So very important to remember to do that. That's the number one thing that goes wrong. You forget a plus sign. Okay, we can continue going here. We have another scatter plot, but this time we're going to use the facet wrap command that I told you about in an earlier lab that you already used to generate 3 graphs side by side one for each ethnic group, for Hispanic, for Black, and for other. So this will be the scatter plot of the relationship between experience and the wage. And then we have our fourth figure, which is going to be another box plot, so where we're going to have a GED. Then we have our regression commands. We've done all this many times. So notice what we're doing with the regression command. We're just going to have the Mincer equation. The log of wage is the outcome, highest grade completed, plus experience squared. And so the syntax to include experience squared here is to write this capital I and parentheses, and then have the experience squared inside the parentheses. Then we're going to also have a second specification where we'll add this ethnic group. Since the ethnic group is a categorical variable, it's going to automatically, R will automatically create two dummy variables and drop one. And it will create dummy variables for Black and Hispanic and drop other. That's our second specification. And then we're going to subset the data, the NLSY data set, to just have those who identify as Black, to just have those who identify as Hispanic, and to just have those who identify as other, and run regression separately for each one of them. That way we'll have the effect of highest grade completed separately for each ethnic group. And our last, here's the, of course, the, we put all the models into a list. Here I'm giving each model a short name so that the columns will show these names rather than 1, 2, 3, 4, 5. Very straightforward little advance you can do in model summary. So we create a list of our 5 regressions with their labels, and then we call that models, that list, and then we use the model summary command. Here again, I'm going to call the model summary output XX. I'm assigning it to the object XX, and then I'm going to pipe XX here into this Cable Classic formatting command, so it'll look better. And finally, we have a couple of regressions at the very end here, where we are going to now not have highest grade completed, but have whether or not you have the GED, a dummy variable, whether or not you have the GED, and then the interaction of whether you have the GED and whether you're Black, and whether you have the GED and whether you're Hispanic. So we'll have some interaction terms in this. So this regression equation is a log linear. We have the log here. It's a log linear specification. It has a polynomial. And it has interaction terms. Dummy variables, these are dummy, GED is a dummy variable, Black is a dummy variable, GED is a dummy variable, Hispanic is a dummy variable. So we've got all the different kinds of specifications sort of in this one equation. And then we have our same model summary command to display the regression results.